Hello, my name is Jordan Deyton, and I'm a Postmaster Research Associate at Oak Ridge National Lab and a developer for the NiCE Integrated Computational Environment. Today, I'm going to be demonstrating nuclear reactor analysis capabilities provided by NiCE's Reactor Analyzer package. First, I will give you a brief introduction to NiCE, then I will give you a guided tour of the Reactor Analyzer in NiCE, followed by a summary of the steps involved in reactor analysis. So, what is NiCE? NiCE is a cross-platform, 100% open source workflow and data management application. When coming up with the idea of NiCE, we realized that there is a standard model of scientific computing. All computational scientists, from the newest user to the most skilled researcher, have a general workflow that involves developing simulation input, launching the code, analyzing the output, and archiving the data. NiCE offers a standardized, simple interface to each of these tasks and reduces the time and effort needed to, for instance, write scripts for generating input or learning how to queue jobs for a particular computing platform. In this video, I will demonstrate analysis capabilities offered by NiCE's Reactor Analyzer. Once you have opened NiCE, you will be presented with this screen. Before we begin, we need to have some sort of data to analyze. To get data into NiCE, your files have to be stored in a particular location so that NiCE can find it. If you have not already imported your data into NiCE, then you need to click on one of the import buttons. You can import files via the File menu or the toolbar. Once you have found your data files, you can click OK. Now we need to create an instance of the Reactor Analyzer. In NiCE, we have what we call items for individual tasks that we support. To create an item, we have three options. We can click the green plus button in the item viewer on the left, we have a shortcut button on the toolbar, and we have a button within the File menu. Once the item selector window appears, we are presented with a list of items or tasks that you can use in NiCE. For model input, we have model builders. For launching jobs, we have launchers. And for analysis, we have analyzers. We also have a handful of other items for other codes, but to analyze reactors, we need to create a Reactor Analyzer. Select the Reactor Analyzer and click OK. NiCE should present you with the Reactor Analyzer. From now on, we do not really need any of the other views offered by NiCE, so go ahead and click on the Reactor Analyzer tab at the top to maximize it. The first step is loading the analysis data. Since we previously imported our data into NiCE, we can select them for the input and reference in the Reactor Analyzer and click Save. The first thing you will notice is that the pictures below changed. These are both the reactor core views of the input data's reactor. We can change what is displayed by clicking on the Views button in the top right corner of each section. In the Reactor Analyzer, we have four possible views: reactor, fuel assembly, fuel rod, and plot, and you can switch to each of these views for both the input and the reference reactors. Since we aren't looking at the reference reactor yet, let me switch the right section to the reference reactor view by clicking on the Views button on the far right. You may notice that the reference reactor core looks a lot smaller. This is because our reference reactor is only a single fuel assembly, while the input reactor is a 15 by 15 core with various assembly types. In the reactor view, you can display different assembly types by clicking on the Data Types button. Currently, the supported assembly types are fuel assemblies, control banks, in-core instruments, and rod cluster assemblies. Red locations in the core are unselected assemblies, while the green location is the currently selected assembly. Since we really care about fuel assemblies, let's switch to the fuel assembly views for both the input and the reference. The fuel assembly view initially presents you with a geometric view of the fuel assembly. On the left, you have a radial view of 1/8 of the fuel assembly, and you can make out fuel rods with the occasional guide tube. On the right, you have a scale and an axial view of one of the rods to give you an idea of the composition of these rods. In this view, you can look at the data by clicking on Display Type and selecting State Point Data. Initially, we have not selected a feature of data to display, so let's go ahead and pick Pin Power under the Data Feature button. If you want to take a look at other symmetries, you can use the Symmetry button to pick between an 1/8, a 1/4, and a full assembly view. So right now, we're looking at the average pin powers for the input reactor's only fuel assembly. Let's switch the data feature to axial pin power and take a look at how the pin powers look throughout the assembly. Notice how all of the fuel rods went blue? That is because we are looking at the very edge of the fuel assembly. We can use the scale on the right to adjust which axial level we are viewing. So it's colder on the top and bottom of the fuel assembly than it is in the middle, right? Let's take a closer look at one of the middle axial levels. If we want to see how the rods compare at this axial level, we can switch the extrema to mins and maxes local to the current axial level by clicking on the Data Extrema button. Again, pin powers are lower in the four corners and higher elsewhere. Suppose we need to take a closer look at an individual rod, like one of the hot ones. We can set the view on the right to look at the input fuel rod. Initially, this view is blank because we have not selected a fuel rod yet. So, back in the fuel assembly view, select the rod of interest by left-clicking on it. Really, the fuel rod view is very similar to the fuel assembly view, but it only shows a single rod. Since it's focused on an individual rod, you can easily pick out different components of the rod. The green part is the clad, the yellow is the helium fill gas, and the red is the uranium fuel. You can also change the rod view to include state point data by clicking on display type and selecting it from the drop-down. Of course, the fuel rod view will change when you select other rods in the fuel assembly. You can even look at guide tubes if you like. Currently, the fuel rod view is limited in what it shows. Here you can see the average pin power inside the radial view of the rod and the axial pin power in the axial view. Eventually, we will make this view more customizable, including allowing you to use the axial view and the scale next to it to cycle through the different sections of materials composing the rod. The last view for the reactor analyzer is the plot view. With the plot view, you can plot the axial pin powers for each fuel rod. Let's switch the left view to the input plot and the right view to the reference plot. Now we get blank charts. To add axial pin powers to the charts, you need to click on Select Plotted Series. This pops up a dialog displaying the currently selected fuel assembly. This feature is relatively new and is built on the Eclipse graphical editing framework. What this allows us to do is select multiple figures displayed on the screen. You can click once on a fuel rod to select it. You can also click and drag to select multiple fuel rods. If you hold Control while you do this, it inverts the selection done by click and dragging. If you hold Shift, it appends the selection done by click and dragging. Right-clicking deselects everything. For now, let's just add a few rods, say F7 and F8. These rods are almost identical, so let's swap F8 for something along the edge like B2. Let's select the same rods for the reference data. You'll notice that our input and reference data are very similar for these two rods, so it would be helpful if we could look at the actual differences between them instead. To solve this problem, we can switch to the Analysis Configuration tab. Just click on the tab at the bottom of the window. This page allows us to select a pre-programmed strategy for mining or analyzing our data. Just click Add and select one of the strategies that is available. In our case, we only have what we call the Godfrey strategy. Among other things, it computes the axial pin power differences between the assemblies, so let's add it. To run the Godfrey strategy, in the top right next to Process, select Generate Analysis Artifacts and click Go. If the strategy outputs anything to standard output, it will be fed through the console. In this case, there's nothing important to see, so let's check out the file it just created. Switch to the Analysis Artifacts tab at the bottom of the window. Here you have the file that was just generated by the Godfrey strategy. If you open the Resources view, you can see where the file was written to if you want to export it into a spreadsheet. Now that we've run the strategy we need, let's go back to the Reactor and Fuel Assembly tab. Now let's switch the right view to Comparison Plot and add in the two rods of interest, F7 and B2. And there we have the differences for these two rods. You can see that the differences are actually quite small and that our input data is accurate up to the thousandths. This about wraps up my tour of the Reactor Analyzer, but first, there are a few more things that I'd like to show you. You may have noticed the Save Image button that appeared in all of the Reactor's views. This button allows you to export the graphics you see as images. You can also access every button in the view's toolbars by right-clicking on the view. So, to save the plot of the differences that we just created, I can either click on the toolbar button or I can right click on the plot and click Save Image. You can save the picture as a bitmap, JPEG, or GIF image and share it on Facebook or tweet it to your colleagues. In conclusion, I showed you how to get your data into the Reactor Analyzer, specifically how to import it into NiCE and how to load the imported data. Then, I showed you how to explore the different levels of the light water reactor core, starting with the reactor view, followed by the fuel assembly view, and then the rod view. I then showed you how to plot the input and reference data. We were able to run a data mining strategy on our data, and then we plotted the comparison data from that strategy. We hope this video has been helpful for you, and we very much appreciate any feedback you may have. If you have any questions or comments, feel free to visit our website or contact us through email. Please check out the other videos on our channel and feel free to subscribe. Thank you for watching and have a fantastic day.